Okay, right. Coming to the ruby laser, I'm going to direct to the ruby laser. So here, ruby laser is the first invented laser by the Marmin in 1960. So before going to discuss about the ruby laser, wait a minute. Yeah. In every type of laser, to explain about every type of laser, three things are must here. First one is the active medium. All of you try to remember active medium. So active medium consisting of active particles, and second thing is pumping source. Pumping source. Using the pumping mechanism and achievement of population inversion. How we achieve the population inversion? So in the pumping source, after that we are going to discuss about the metastable state also. In the construction part only, we discussed about the metastable state, and after the population inversion, getting the laser. These steps are must. All of you try to remember. So coming to the ruby laser, I am taken first of all with the construction. In the construction part, we are taken one ruby crystal. One ruby crystal. This is the ruby crystal. So ruby crystal having aluminum oxide ions Al2O3. So for that I am going to add Cr2O3 ions in the percent of 0.05. Because aluminum oxide particles are absent, only chromium particle are taken the total laser transition. That's why I am going to add for aluminum oxide, chromium oxide ions. So Cr chromium particles are responsible for the total transition here. I will explain. Try to remember. This is the ruby rod or ruby crystal. Ruby crystal having aluminum oxide ions actually. For that I am going 0.0, I am mixing 0.05% of chromium oxide ions. So two ends of the ruby crystal are silvered. These two ends are silvered. One is fully silvered, 100% silver. And another thing is 90, another side is 95% partially reflected mirror. This is 95% reflected mirror. Two ends are silvered here. One end is fully silvered and one end is partially silvered. These two polished ends is acted as a resonant cavity. Resonant cavity. Resonant cavity. To give the optical feedback to the photons, we are using these two mirrors. So this aluminum or ruby crystal we are keeping in xenon flash tube. Illogical xenon flash tube. This is the flash tube. It is connected to the power source. This is a capacitor bank connected to power source. Capacitor potential we are going to apply it. Okay, and this is the construction part. While getting the laser, so all operators are very heated. So total operation we are conducting in cooling chamber. This is a cooling chamber. This is a rough diagram for the ruby crystal or ruby laser. This is the inlet. This is the outlet. We are using liquid nitrogen or water. Liquid N2. Liquid nitrogen or cool water used as a coolant. So while getting the laser, total operators are very heated. There is a chance to damage the operator. That's why we are total operation we are conducting in cooling chamber. This is a cooling chamber. So here liquid nitrogen or cool water is used as a coolant here. So coming to the construction of the again ruby laser consisting of ruby crystal with the aluminum oxide ions with the percentage of 0.05% of chromium oxide ions mixing to the aluminum oxide ions. Okay, so two ends of the ruby crystal are silvered. One end is partially silvered and one end is fully silvered. So this partially silvered end only we are getting the is coming from the partially silvered end. So this ruby crystal I am keeping within the flash tube, xenon flash tube. One second. This is the xenon flash tube. Helical xenon flash tube. And this is the pumping source actually. The ruby laser, this is a pumping source, optical pumping source. So which is connected to the capacitor bank and power source. And these total operation we are conducting in within the cooling chamber. So here liquid nitrogen or water is used as a coolant. So in the construction part is totally over. Construction is over. Now coming to the active medium. So here total lasing transition takes place within the ruby crystal. That's why active medium is ruby crystal. Ruby crystal. Here ruby crystal consisting of aluminum and oxygen and chromium particles, but not all the particles are responsible for the laser transition. Only chromium particles are responsible for the Cr3 plus ions only. Wait, Anna, wait for a minute. Active particles are chromium 3 plus ions are the active particle because of total laser transition takes place within the chromium energy levels. Within the chromium energy levels, total laser transition takes place. That's why chromium ions are active particles. Coming to the Is I'm audible, Amma? Is I'm audible?
Yes, sir.
Yes, sir.
Okay. Uh, up to where we are discussed, Amma, about the ruby laser. ఏం డిస్కస్ చేసాం రూబీ లేజర్ గురించి ఎక్కడ వరకు డిస్కస్ చేసాం all of you try to remember the points like we started with construction. Listen, we started with the construction. After that we have to discuss about active medium and active particles. So after that pumping mechanism, which type of pumping source we are using to exit the particles from lower energy state to the higher energy state. The population inversion, how we are getting the laser transition levels, that we are going to discuss. After that some applications about the ruby laser also we are going to cover. Directly I will show the PPT, Amma. With the PPT only I am going to explain. This is the construction of the ruby laser. Ruby laser consisting of cylindrical shaped ruby crystal rod. One of the end faces is highly silvered and the other face is partially silvered, so that it remains 10 to 25% of incident light and reflects the rest. The ruby crystal placed along the axis of the hilal. This is surrounded by a reflector. The ruby rod is protected from heat by enclosing in a hollow tube through which cold water is circulated. Nothing but cooling chamber. Total operation takes place in the cooling chamber. The ends of the flash lamp are connected to the pulsed high voltage source, so that lamp gives flashes of intense light. This is about construction. And this is the diagram for ruby crystal. So coming to the working, the chromium ions are responsible for the stimulated emission of radiation. Coming to the energy level diagram, with the energy level diagram, how it will be.
Sir, voice is not audible, sir.
Thank you, Amma. Thank you. So this is example for 3-level energy scheme. So 3 energy level E3 and E4 is called as only one energy level because of where this blue absorption, blue energy level and green energy level are both are very much close to each other. That's why we are treated as only one energy level. So usually chromium particles are presenting in the ground state. This total operation takes place within the ruby crystal. This total ruby crystal, total operation we are conducting within the ruby crystal. So two ends are silvered here. These two ends are act as a resonant cavity. So this ruby crystal we are keeping in xenon flash tube na. So when the flashlight is on, so that flash lamp is circulated within the xenon flash tube. So from the flash lamp, only green and blue absorption is observed by the chromium particles in the ground state and excited to the higher energy states E3 and E4. From the flash lamp, only green and blue, these two wavelengths are observed by the chromium particles in the ground state and excited to the higher energy states E3 and E4. So after exciting the particles which are available in the E3 and E4, they are interacting with the lattice. When they are interacting with the lattice, lose some energy and de-excited to the metastable state E2. This is non-radiative transition. We call as non-radiative transition. So due to non-radiative transition, no energy is released, no photons are released in the de-excitation process. With the interacting with the crystal lattice, what will happen? So the atom or the particles loses some energy and de-excited to the metastable state. So in the what is the purpose of metastable state? Atoms are spending maximum time in the metastable state. That's why atoms are continuously goes on increasing. At the same time, using the pumping source or using the xenon flash tube, we are sending particles from ground state to the higher energy states E3 and E4. By sending the particles from ground state to E3 and E4, your particles are goes on decreasing. At the same time, due to spending of maximum time, your particles are goes on increasing in the E2 energy level. At a particular instant, what we are going to observe, the number of particles in the E2 state or the number of chromium particles in the E2 state is greater than to the E1. Means we achieved the population inversion. Population inversion we achieved in between the energy levels E2 to E1. Population inversion. Right? So how we achieve the population inversion? Due to the metastable state and due to the pumping mechanism, we achieved E2 and E4. E3 and E4 we treated as only one energy level because of the energy levels are very close to each other. So when the flash lamp is circulated within the flash tube, so from the flash lamp, the chromium particles in the ground state observe only blue and green absorption and excited to the energy levels E3 and E4. So after that, what will happen? By the non-radiative transition, they are appear in the metastable state, or by interacting with the crystal lattice, they are losing some energy. When they are lose some energy, they are de-excited to the next energy level, nothing but E2. So E2 is called as a metastable state. That's why atoms are holding maximum time in the E2 energy state. That's why your particles are goes on increasing. So at the same time, due to sending of particles from ground state to E3 and E4, your particles are goes on decreasing. At a particular instant, we observe the population inversion between the E2 and E1. What is population inversion? The number of particles in the higher energy state is greater than to the lower energy state is called as population inversion. Means we achieve the population inversion. After achievement of population inversion, the final thing is getting the laser only remains. So how we are going to get the laser? How we are observing the laser here? See. So for example, this is the first coming atom to the metastable state. After completion of lifetime, what will happen between the energy levels? So the atom automatically de-excited to the ground state energy level. That is by the spontaneous emission. By the spontaneous emission, atom is de-excited to the chromium particles are de-excited to the ground state energy level with emitting of photon. Only one photon is released. This photon may be supplied to one more or absorbed by the one more atom in the metastable state. By observing the energy, the atom is de-excited to the ground state energy levels by the stimulated emission, the two energy levels. By the stimulated emission, so two photons are released here, which are in phase, which are very coherent. So the two photons are released by the stimulated emission of radiation. Again, these two energies are maybe supplied to the two more atoms in the metastable state. Observing these energy by the photons observed by the particles and de-excited to the ground state energy level again. So here one is converting into the 2 and 2 is converting into the 4 again. So each transition 2 photons are released here. So again four photons are maybe supplied to the 4 more atoms in the metastable state and absorbs that energy and de-excited to the ground state energy level. Here 4 atoms are de-excited to the ground state energy level. Means 4 into 2, 8 photons are released. Like that, the energy is intense. So up to sufficient intense. So this process is occurred between the energy levels. By the pumping source, the de-excited chromium particles are excited to the higher energy states. So by interacting with the crystal lattice, they are de-excited to the metastable state. So after the metastable state, either by stimulated emission of radiation or spontaneous emission of radiation, the particles are de-excited to the ground state energy level with emitting of photons. Right? This is converting into the laser beam finally after sufficient intense. So that photons are releasing as a laser beam from the output laser, output N. So 95% silver N is acted as a output one. Okay, so up to sufficient intense, these photons are get multiple reflections between the mirrors here. Get back here also by getting the multiple reflections. So this is reflected back in between the two mirrors, and this is a process or laser transition takes place within the energy level of ruby crystal. So total action takes place within the ruby crystal. That's why active medium is ruby crystal. Active particles are only chromium particles because from the flash tube only green and blue absorption is observed by the chromium particles. Green and blue wavelength is observed by the chromium particles and excited to the higher energy state. These total particles are only chromium particles. Excite IAD, de-excite IAD. That's why only chromium particles are responsible or active particles in the active particles in the ruby crystal. That Al2O3 aluminum oxide particles are absent. They are not absorbing any wavelength from the flash tube. Only chromium particles are 57. What happened? 57.
By mistake, sir. Sorry, sir.
Okay, chromium particles, only chromium particles are responsible for the transition. Remaining all are absent. So again, active medium is ruby crystal, active particles are chromium particles, and xenon flash tube is a pumping source, is called as optical pumping, and two silver ends are acted as a resonant cavity, and laser transition takes place within the chromium energy levels. So these are 3 level schema. So energy levels are 3 only: ground state, first excited state, and second excited state. Second excited state having 2 energy levels, but we are treated as only one because of blue and green, and E3 and E4. What we are taken in the diagram, E3 and E4 is treated as only one energy level because of they is close to each other. Okay. So first from the flash lamp, only green and blue absorption is observed by the chromium particles and excited to the higher energy states E3 and E4. So after that, by the non-radiative transition, they are de-excited to the metastable state. Non-radiative, that's why we are calling non-radiative. There is no energy is released in the de-excitation process. That's why we call as non-radiative transition. So in the metastable state, atoms are spending maximum time. That's why atoms are continuously goes on increasing in the E2 state. At the same time, particles from the ground state by exciting from ground state to the higher energy state, particles are goes on decreasing in the ground state energy level. At a particular instant, we observe the number of particles in the E2 state is greater than to the E1 is called as population inversion. So after achieve the population inversion, getting the laser. So to start the stimulating emission process, we are using here spontaneous emission because of there is no possibility to give external energy to the atoms which are available in the E2 state. That's why if first coming atom by the spontaneous emission or first coming particle by that spontaneous emission, that particle is de-excited to the ground state energy level. By the de-excitation, what we are going to observe, only one photon is released. That photon may be supplied to the particle which is available in the E2 state. So that energy observed by the particle and de-excited, that's why stimulated emission of radiation will starts now. So by the stimulating emission, so two photons are released in the second transition. So the two photons again may be observed by the two more particles in the E2 state and de-excited to the ground state energy level by the stimulated emission. So two photons are released by the two transition, means four photons are released. So one is converting into the two and two are converting into the four, or four is converting into the eight. That's why. So in the cascade process, energy is intense. After sufficient intense, what will happen? Laser beam coming from the output, partially reflected mirror. And this is the total transition takes place. This is about the ruby crystal, ruby laser. Wait. Now this is this is the three-level diagram for ruby crystallama. Ground state is E1, metastable state E2, and these are three. Blue and green absorption is called as a third energy state, very close to each other. Okay. For the pumping light, only blue and green absorption by observed by the chromium particles from the ground state and excited to the higher energy state. So laser transition is one more thing, amma. Here forget to tell the wavelength. 6943 angstroms of wavelength is produced in the ruby laser, which is in the red color. 6943 angstroms of wavelength. These some applications of ruby laser. Ruby laser used in distance measurement using pulse echo technique, and ruby laser is used to create a holograms of large objects. And used in atmospheric ranging, used for trimming resistors and integrated circuits. Means in making of electronic devices, we are using ruby laser. And ruby laser were used mainly in research one of the
Sir, your voice is not audible, sir.
ఇప్పుడు చెప్తున్నారేంద్ర నాయన ఇప్పుడు చెప్తున్నారేంద్ర నాయన నేను అప్పటి నుండి మొత్తుకుంటున్నా సరే ఓకే సో టుమారో we are going to discuss about the ruby laser again and going to cover the helium neon laser also.